Hey there, our SD teachers, and welcome back to the classroom. We know you are incredibly busy setting up your rooms, prepping materials, and just getting everything ready to go. So let's jump right into your playbook for teaching Grade 3, Unit 1. It's called Onward We Go. Think of this explainer as your essential, no-fluff guide to confidently delivering this unit. Okay, let's dive right in.
So, here is our game plan today. 1. Unit Teaks and Student Mastery. 2. Course Science Concepts Explained. 3. Addressing Common Student Misconceptions. 4. Investigations and Necessary Modifications. And 5. Vocabulary and Interactive Word Wall.
All right, Part 1. Unit TES and Student Mastery. Starting with the end in mind.
Now, translating the academic language of our standards into plain English is absolutely crucial. The 4 fundamental teaks for this unit mean we are really focusing on getting your students to actively practice scientific inquiry and engineer solutions to problems. We also want them using basic math to find patterns in their data, and ultimately recognizing how these scientific innovations actually impact our everyday society and even potential STEM careers.
And this right here brilliantly illustrates our ultimate mastery goal, which basically serves as the big idea for the entire unit. By the end of these lessons, a successful third grader will understand that investigating and problem solving is literally what science is all about. You see, mastery isn't just about memorizing facts, right? It's about adopting that active, curious, questioning mindset of a real scientist or an engineer.
Moving on to Part 2, Core Science Concepts Explained. Let's build your foundation.
Okay, this sequence represents the descriptive investigation process. It's essentially a clear, repeatable roadmap for observing the natural world. First, they ask a question. Then, they make a prediction about what they think is going to happen. They plan their steps, safely conduct the experiment, record their data in their science notebooks, and finally, they communicate their results. You'll actually be introducing these steps on day 3, and this structure will beautifully anchor their scientific thinking all year long.
Now, when they put on their engineering hats, they're going to use the engineering design process. And unlike a simple one-and-done checklist, this is a continuous loop for problem solving. Students identify a problem, make a plan, develop and test a prototype, and then, and this is the most important part, they improve it. Seriously, please remind your students not to worry about getting it perfect on the first try. Improving the prototype based on a failed test is a highly celebrated and essential part of the learning process.
So, to tie both the science and engineering processes together, you'll be teaching the CER framework. That stands for Claim, Evidence, and Reasoning. Introduced earlier in the unit, this tool is a total game changer. It ensures students answer questions using specific observations and data from their labs, which is their evidence, rather than just guessing wildly. Their reasoning then connects that solid evidence directly back to their original claim. Section 3. Addressing Common Student Misconceptions. Avoiding the pitfalls. First up, students often have this idea that science is just a static textbook of facts that have all already been discovered by someone else. But you'll want to reinforce that it is actually a dynamic, never-ending process of discovery. We are always asking new questions and learning new things.
Another huge misconception is that models are perfect, exact replicas of the real thing. Be sure to explicitly point out that every single model, whether it's a conceptual drawing on your whiteboard, a physical bridge made out of candy, or a mathematical graph, is just a simplification. Each model has its own unique advantages for learning, but they also have very real limitations based on their size, scale, or what materials were used.
Finally, we really have to bust that lone genius myth. You know the one, the idea of a scientist working completely alone in a dark, secret lab. Contrast that with the reality. Science is an incredibly social process. It absolutely requires teamwork, communication, and respectful debate to succeed. This is exactly why your students will practice communicating their results and being active, respectful listeners in class.
All right, let's get to Part 4, Investigations and Necessary Modifications, your action plan.
Your very first major hands-on lab happens on day 4, the soap and germs model. It's a fantastic, super simple setup to practice a descriptive investigation. Students will use a plastic plate with water and sprinkle ordinary pepper on top to represent germs. When they introduce a tiny drop of dish soap, they will visually observe and record how the soap instantly repels the pepper. It's quick, it's highly visual, and it models hand washing perfectly. Your main job here is just to ensure they are accurately recording their observations and actually explaining why the tools and safety rules matter during the lab.
Next up, on day 5, we have the gumdrop bridge. Now this is where they really practice the engineering design process. You're going to challenge them to build a prototype bridge across a 15-centimeter gap using only gumdrops, toothpicks, and an index card. Their testing metric is incredibly simple. Just how many pennies can the prototype hold before it completely fails? They'll record their baseline penny count, evaluate their structure, and then, here's the loop, rebuild it to improve their design. Really keep an eye out for those light bulb moments when they realize a stronger base or a different shape holds way more weight.
Now we know your classrooms are diverse, so consider this your screenshot-worthy cheat sheet for supporting emergent bilingual students across both of these labs. For your beginning language learners, utilize lots of physical gestures during the SOAP prediction and show them actual photos of real bridges before they even start building. For your intermediate learners, try providing partially completed observation tables and labeled diagrams. That way they can focus on the core concepts, not just vocabulary retrieval. And for your advanced folks, push their critical thinking. Ask them to design a modified version of the SOAP investigation or articulate exactly why their second bridge design held more pennies than the first one did.
And finally, Part 5, Vocabulary and Interactive Word Wall, Mastering the Language.
The key content vocabulary words for this unit include terms like criteria, prototype, and innovation. These are the absolute non-negotiable terms your students need to master so they can confidently discuss their investigations and engineering designs using proper academic language.
To make these big words really stick, we use total physical response, or TPR, motions when adding them to the interactive word wall. Here is the exact physical script you should use in class. When you introduce the word science, have your students physically pretend to look through a microscope. For discovery, have them make a big, exaggerated, surprised face with their hands on their cheeks. Honestly, getting them moving like this builds incredible muscle memory for the vocabulary. It works like a charm.
Let's go over a couple more crucial ones. For descriptive investigation, have them pretend to write on a clipboard, acting like real researchers out in the field. And for criteria, they should hold up their fingers to physically count out the rules or requirements of their project.
By tying these playful physical motions directly to the core TEKs and the hands-on labs we just covered, you're setting your students up for some incredible success. The scaffolding is all right there for you, from clear, plain language goals to simple frameworks to engaging models that help every single learner grasp the content.
Well, you are absolutely ready to confidently teach Onward We Go starting tomorrow morning. As you head into your classroom to guide these brilliant young scientists and engineers, we want to leave you with this one exciting thought. How will the innovative solutions your third graders dream up today shape our society tomorrow? Have a fantastic unit, everybody.